So in this video, I'm going to go over the Unit 4 test review. So first of all, with number 1, and with all of these problems, y'all should look for a GCF first, okay? Because that makes the problem a lot easier. So I notice that all of these are divisible by 4. So if I divide 4r squared by 4, I get r squared minus 3r minus 18. Then I'm going to multiply my first and last terms together here. That gives me negative 18r squared. So then I'm looking at the factors of negative 18 that add up to be negative 3. And so I know, again, my factor's 4 here, that I have 1 and 18, 2 and 9, 3 and 6. And because this is a negative number, one of those is going to be negative, one's going to be positive. And the middle number is negative, so the bigger number is going to be negative. So right here is where I get my sum of negative 3, which is this term right here. So that means that I'm going to put r here and r here, because that's what I put down there for my factors, and then I'm going to do plus 3 and minus 6. Maybe. There it goes. Okay. So for number 2 here, I recognize immediately that these are both perfect squares. So I'm looking at this for a special pattern here. So this is, if I take the square root of 121m squared, I get 11m. So I'm going to put that in both sets of parentheses. And then if I take the square root of the 81, I get 9. And I'm putting that in both sets of parentheses. And hopefully you remember that the pattern here is plus and minus. And that's just how I factor that with the special pattern. Number 3, very similar. The only difference is we have a GCF. So what we're going to do is factor out that GCF first. And once again, you should notice that we have 2 perfect squares here. So we're going to take square root of this and the square root of this. We're going to bring down that 3. We're going to put our x here in both sets of parentheses. And then we're going to put 10 and 10, because that's the square root of 100. And we're going to put plus and minus again. So this too was a special pattern. So number 4, this one says to factor each completely. I again notice that my first and last terms, my first and second terms, I should say here, are perfect squares. So I'm going to take a square root of 25x squared, and I'm going to put 5x here and 5x here. Then I'm going to take the square root of the 36, and I'm going to put 6 here and 6 here. Now, whoa, wait a minute. I got a plus sign here. Do y'all notice that? Well, that tells me that this term, this second term, when I multiply 6 times, if I were to go plus and minus here, that would give me a negative 36, but this is a positive 36. And the way that I know that this is going to be imaginary is because I can do 6i times negative 6i. So if I do 6i times negative 6i, don't I get negative 36i squared? And what is I squared, y'all? So this would be negative 36 times negative 1, right? Because I squared equals negative 1. So that's what makes this a plus 36, okay? So you guys need to really pay attention to this when y'all are taking the test, because this is a question a lot of people missed on that first quiz. So if there's a plus sign between 2 perfect squares, then you're going to have imaginary factors, okay? All right, so this one again, I'm going to see if it has a GCF. So I'm going to divide it by 2 and 3 and 4 and 6 and 8 and see which one of those is the greatest common factor. Well, when I did that, I found out that 6 went into everything. So when I divide 6 into 24x squared, I get 4x squared. When I divide 6 into 168, I get 28x. And then when I divide 6 into 294, I get 49. Okay, now let's pause, take a step back here and look at this problem. Do you guys notice that the first number, 4x squared, is a perfect square and the last number is a perfect square? So I'm going to take the square root of this. I'm going to bring that 6 down, and I'm going to put 2x here. And I'm going to take the square root of this, and that gives me a 7. And I'm going to look at the sign in the middle here. Y'all see this plus sign right here, and I'm going to bring it down. Now, if when I multiply these two terms together times 2, I get the middle term right here, then this is a binomial squared. So to make sure that this is a binomial squared, I'm going to multiply 2x times 7, and then I'm going to multiply that by 2. Well, what is that, y'all? 14x times 2 is 28x. That's our middle term, isn't it? So that means this is a binomial squared. Here again, we're going to divide all these numbers to see if there's a GCF. So I would divide 24 by 2, 72 by 2, 54 by 2. Do that with 3, do that with 4, do that with 6, do that with 8. Y'all follow me here? And see where my GCF is. Well, I discovered that 6 was my GCF again. So we're going to get 4r squared, here again. Divided 6 into negative 72, that's negative 12r. Divided 6 into 54, that's 9. Okay, so once again, take a step back here and see if you see what I see. I see a perfect square in the first position and a perfect square in the last. So the same pattern that we did last time applies here, only one key difference. So we got a 2r there. Take the square root here, put the 3 here. See this sign right here? That we're going to put that right there. Now, once again, to determine if this is a binomial squared, we're going to multiply 2r times negative 3 times 2. That would be negative 6r times 2. That's negative 12r, right? And yes, indeed, that is our middle term. So that means this is a binomial squared. Here's another special pattern. So because I have an x to the third and a y to the third in this problem, my guess is that these are two perfect cubes, the sum of two perfect cubes. So to try to see if that's true, then I'm going to take 125 to the 1/3 power, that's 5. And when I take the cube root of x to the third, that's x. Going to keep working across here. We're going to take 8 to the 1/3 power. That's the cube root, by the way, and so that's 2. And then we're going to take the cube root of y to the third, that's y. Now what we're going to do with these terms is we're going to put them in a set of parentheses with the same sign. So we're going to do 5x plus 2y. Now for our second set of parentheses, we're going to take our first term, 5x, and we're going to square it. For our middle term, we're going to multiply the two terms together. So we're going to do 5x times 2y, and whatever the sign was in the first set of parentheses, the sign of this middle term is going to be opposite it. So if it was plus, we're going to make it minus. If it was minus, we're going to make it plus. And then for our last term, we're going to square the second term in that first set of parentheses. So we're going to square the 2y. So now all we have to do is simplify. So this is 5x plus 2y. 5x squared is 25x squared. This is going to be minus 10xy. And this is going to be 4y squared. So our next one is similar. So once again, we're going to take 125 to the 1/3 power. That's going to be 5. We're going to take the cube root of x cubed. So that's going to be x. We're going to take 64 to the 1/3 power. That's going to be 4. We're going to take the cube root of y to the third, that's y. And we're going to keep that sign, the minus. So once again, our process is taking that first term, 5x, and squaring it, multiplying the two terms together, the 5x times the 4y. Now remember, I said if the sign in the first set of parentheses is a minus, which we got from up here, then the sign in the second one's going to be opposite that. So that's going to be a plus. And then we're going to square the 4y. So our final answer will be 5x minus 4y times 25x squared, because 5 squared is 25 and x squared is x, plus this is 20xy, and then 4y squared is 16y squared. So that's how we factor the difference of two cubes. So for number 9, the very first thing we have to do is move all of the terms to the left side. So we're going to add 2b to both sides here. So then we get 3b squared plus 13b minus 30 equals 0. Okay, we're always going to do that first. Now, I'm looking at this to see if there's a GCF, but 13 is my middle term, and that's a prime number, so I know I can't factor it anymore. So what I'm going to do, because the directions say to solve each by factoring, is we're going to multiply this first and last term together. That's going to give us negative 90b squared. So then we're looking for the factors of 90. So I'm always going to start with something I know is really, it's going to go in there, which would be like 10 and 5, right? So 10, if I go 9 times 10, that's 90, right? If my middle term is positive, then obviously my bigger term would have to be positive. Well, obviously that's not going to give me, that's going to give me 1, not 13, right? So then let's divide this thing by 5. So 5, so if we divide 90 by 5, we get 18. So once again, we want our smaller number to be negative, our bigger number to be positive. So yep, right there we get 13, the number we were looking for, right? So remember this one. We're going to bring down our coefficient with our b. So we're going to put 3b in the set of parentheses over here. Sorry, y'all can't write, obviously, very well. 3b here and 3b here, right? So then we're going to put our factors that we got, minus 5 and plus 18. This is still equal to 0. So now remember, we can't simplify what's on the left, but on the right there's a GCF. So we're going to simplify this. So this can be divided by 3, so this can be b plus 6. So our two factors are 3b minus 5 and b plus 6, okay? Now, to solve this, we have to set these factors equal to 0, okay? So that's what we're going to do next. We're going to set these factors equal to 0. So we're going to do 3b minus 5 equals 0. So we're going to add 5 to both sides. So then we got 3b equals 5, right? Then we're going to divide both sides by 3. So b is equal to 5 over 3. That's one of our solutions. Then we're going to set this b plus 6 equal to 0 as well. So we're going to subtract 6 from both sides. So b is equal to negative 6. So those are our two solutions right there. So again, with number 10, we're going to move that 320 first to the other side. So we got 24p squared minus 232p plus 320. That equals 0, right? So again, I'm going to see if there's a GCF here. So I'm going to divide everything by 2, by 4, by 3, by 4, by 6, by 8. And when I did that, I figured out that 8 was the greatest common factor, right? So we're going to do 8, because again, this is going to help us to factor this. Remember that. So that's 3p squared right here. When we divide 232, we get negative 29p. And when we divide 320 by 8, we get 40. Okay? So now we're going to multiply these two terms together. That gives us 120p squared, right? And then I'm going to just start dividing that by some numbers to figure out where my what my factors are, that when I add them together, I get negative 29. Now, this is what I do know, because this term is positive and the middle term is negative. Both of these terms are going to be negative. So I know this right here, guys. I can bring down that 3p. I know that both these terms are going to be negative. So then I'm just going to start looking at some numbers. And I know that 120 is divisible by 25, right? So I'm going to do 25. So when I divided 120, well, maybe, yeah, actually, I don't know. Let's try that. Let's go 120 divided by 25. Oh, that was 4.8. So let's step it down 1. Let's go 120 divided by, let's do 25. Let's do 5 divided by 5. There it is. Okay, so we've got 5 and 24. Those are our factors, right? And I just told y'all Well, this is not working for me. Okay. 5 and 24, right? So they're both going to be negative because that's going to give me a negative 29. Okay. So when it's a whole number, I mean a zero like that, I'm going to actually start dividing it by stuff that I know it would go into. So that was minus 5 and minus 24. Well, I can't factor the one on the left anymore, but I can factor the one on the right more because there's a GCF of 3. So we get P minus 8. That's 8, y'all. Let me erase that so y'all can read it. So this P minus 8 times what? 3P minus 5, right? Remember, we still had this 8 here, so we're going to bring it down, and that's equal to 0. So I need y'all to remember that the way we get rid of that 8 is by dividing everything by 8. So it's just going to actually go away as we work the problem. And we're going to set our two factors equal to 0. So we got 3P minus 5 equals 0. Add 5 to both sides. So 3P is equal to 5. Then we're going to divide both sides by 3. So P is equal to 5 over 3. That's one of our factors, okay? Then we're going to do P minus 8 equals 0. So we're going to add 8 to both sides. So P is equal to 8. So there's our two factors, okay? So with 11, again, we're going to move everything to the left, okay? So we're going to subtract the 6x, and we're going to subtract the 4x squared, right? So when we do that, we're going to get 98x squared plus, again, I'm going to do minus 6x, sorry, minus 4x squared. Minus 4x squared and minus 6x here. So that's going to give us plus 21x minus 35 equals 0. I'm suspect that 7 is the GCF here, y'all, because I know 7 goes into 21 and negative 35. So I'm going to go ahead and divide 98 by 7 as well and see if that works. And it does. When I multiply 7 times 14, I get 98. So this would be 3x. This would be minus 5. Again, remember, we want to deal with that GCF because it makes it a lot easier for us to factor this thing. Then we're going to multiply these two together. That's going to give us negative 70x squared. And then we're looking at what two factors of negative 70 give me positive 3. Well, that was a pretty easy one because we know that 7 and 10 are factors of 70, right? One of these has to be negative, one has to be positive. So that one's negative, that one's positive. That's what gives us a positive 3, right? So we're going to bring down this 14x again in both sets of parentheses. And then we're going to put our factors in there, minus 7 and plus 10. Now this time we have GCFs for both of these things. So over here we have a 7, right? So we're going to get 2x minus 1, right? And over here we have, what is that, 2? So this is going to be 7x plus 5, right? Now remember, we're going to bring down that 7 as well, set this equal to 0. And so what we're ultimately going to do here is we're going to set these two factors, what's in the parentheses, equal to 0, okay? So that's our next step. So we're going to do 2x minus 1 equals 0, add 1 to both sides. So we get 2x equals 1, divide both sides by 2. So x equals 1/2, that's one of our factors. And then over here, 7x plus 5 equals 0. I'm going to subtract 5 from both sides. So 7x equals negative 5. Then we're going to divide both sides by 7. I don't know why it's slowing down, y'all, but it is. So x is also equal to negative 5 over 7. That's our other factor. Our last factoring problem, I'm going to move everything to the left again. So I'm going to add 7p squared, add 5p, subtract 5 to both sides, okay? So that's going to give me 7p squared plus 5. No, I'm doing plus 5p to minus 39p. So let me see what that is. That's going to give us negative 35p, right? And then we're going to have minus 5 equals 0. So doesn't look to me like this time. Wait a minute. That was wrong, y'all. This is supposed to be 34. Because 5 from negative 39 is negative 34p, right? Okay. So now we're multiplying these two together. That gives us negative 35p squared, right? So hopefully you can very quickly see the factors here. So we're going to do 7p in both set of parentheses again. And if it's negative, then one's going to be positive, one's going to be negative. So I'm going to do minus 35 because it's negative and plus 1, right? So we're going to set each of these equal to 0. Well, this actually can be factored out. So it's going to be p minus 5, right, equals 0. So p is equal to 5 here because we're adding 5 to both sides. And then we got 7p plus 1 equals 0. Subtract 1 from both sides. So 7p equals negative 1. Divide both sides by 7. And so we get p equals negative 1/7. So there are our two answers for this one. And that was our last factoring problem. So our next one is taking the square root. So again, we got to move everything that is got the a squared to the left and everything that's a constant to the other side. So I'm going to subtract 1 from both sides here. That's going to be my first step. So that's going to give me 19a squared equals negative 717. Then we're going to divide that 717 by 19, right? So when I do this, I get a squared equals negative 717 divided by 19. Get rid of the a squared, we're going to actually take the square root of both sides. So we're going to end up with a plus or minus taking the square root. So a is equal to plus or minus. We can take out that negative, right, y'all? Because it could be a negative 1 times the square root of 717 over 19. Now, I'm not going to rationalize this, so I'm just going to leave the answer like this. Plus or minus I square root of 717 over 19. Okay? Next problem, again, we're going to subtract the 14 from both sides. So that's going to give us 7b squared equals 1372. Divide both sides by 7. B squared equals 196. Then we're going to take the square root of both sides. Remembering, we're always going to have two answers here, right, y'all? So b is equal to plus or minus 14. So our next one, again, going to subtract 7 from both sides. So this is going to be 100x squared equals 256. Then we're going to divide both sides by 100, which is going to leave us with x squared equals 256 over 100. Then I'm going to take the square root of both sides. So x is equal to plus or minus the square root of 256 over the square root of 100. So this is equal to 16 over 10, which can be reduced to plus or minus 8 over 5. Remember again, there's always going to be two answers when you're taking a square root, okay? So our next one, add 2 to both sides. So 7b squared is equal to 693. divide both sides by 7. We get that b squared is equal to 99. I'm going to take the square root of both sides. So b is equal to plus or minus the square root of 99. And we can simplify this to be b equals plus or minus the square root of 9 times the square root of 11, right? Which is 3 square root of 11. So plus or minus 3 square root of 11 is our answer. So this one says solve each by completing the square. So when we did these, we're going to move the constant to the other side. So our first step is going to be to subtract 71 from both sides, okay? And after we do that, we're going to add a blank. So we're going to do x squared plus 14x plus blank equals negative 64 plus blank, okay? So now remember, we're going to take the coefficient we're going to take b and divide it by 2. So that's 7, right? We're going to put that down here in a set of parentheses. And then we're going to square that, 7 squared, and we're going to put it back up here in these blanks, okay? So we're going to put this 49 up here and up here, okay? Then we're just going to add those two terms, because remember, what you guys should know is that this right here is equal to this right here, okay? So now we just have to add the two terms that are on the right. So we're doing negative 64 plus 49, which is negative 15. So now to solve this, we're going to take the square root of both sides, right? Because we want to get our x by itself. Remembering that we got plus or minus over there. So this is going to be x plus 7 is equal to plus or minus the square root of negative 15. So then we got x. We're going to subtract 7 to both sides. So this is going to be negative 7 plus or minus. And I'm going to factor this. So this is going to be the square root of 1 times the square root of 15. Negative 1, sorry. So this is going to be x is equal to negative 7 plus or minus I square root of 15. Because 15 does not have a perfect square as a factor. That is as simple as it gets. All right, on the next one, same thing. Going to subtract 93 from both sides. So that's going to give me r squared minus 16r plus blank equals, we're going to get negative 33 over here. Wait. No, sorry, negative 97. I don't know what I was thinking there, y'all. Negative 97 plus blank again. So we're going to take this negative 16, again, take our b, divide it by 2. That gives us what? Negative 8. Down here, we're putting x minus 8 squared. Then we're going to take that negative 8, and we're going to square it. That's going to give us a positive 64. Putting 64 here in this blank and 64 up here. We're going to subtract 97 from 64. That's going to give us our negative 33. That's where I was getting that negative 33 from, y'all. Was jumping ahead. So now we're going to take the square root of both sides again, because we got to get that x by itself. So we got plus or minus over here, the square root of negative 33. So this is going to be x minus 8 is equal to plus or minus, I'm going to go ahead and factor this, negative 1 square root of 33. We all know that the square root of negative 1 is I. So this is going to be x is equal to what? Add 8 to both sides. So we got 8 plus or minus I square root of 33. Two answers because of the plus and minus. Last one, I think, for completing the square. No, we got two more. All right, so here we go again. Going to add the 83 to both sides. So we get b squared minus 10b plus blank equals 75, right, y'all? Plus our blank. So we're going to take our negative 10 divided by 2. That gives us negative 5. That's what we're putting down here in our parentheses. And then we're going to square that negative 5 and put it up here in our blanks. So that gives us 100 over here. So we're going to do x minus 5 equals plus or minus 10. So add 5 to both sides, so x equals 5 plus or minus 10. 5 plus 10 is 15. And 5 minus 10 is 5. Oh, negative 5, sorry. 5 minus 10. All right, so for this next problem, we're going to add 36 to both sides. So that's going to give us x squared minus 6x plus blank equals 44 plus blank. Divide the negative 6 by 2. That gives us negative 3. That's what we're putting down here in our parentheses. Then we're going to do the negative 3 squared. That's going to give us 9. That's what we're putting back up here in this blank. 44 plus 9 is 53, right? So that's equal to 53. So here again, we're going to take our square root of both sides. So this is x minus 3 equals plus or minus the square root of 53. There are no perfect squares that are factors of 53, so x equals, add 3 to both sides. So that is our answer. All right, so this one says find the discriminant of each quadratic equation, then state the number and types of solutions. So this is when we're using ax squared plus bx plus c equals 0, right? So we're going to move everything to one side of the equal sign first. So we're going to add 7 to both sides, okay? So we're going to do that first. 6m squared minus 4m plus 1 equals 0. So our discriminant is the part in the quadratic formula. Here's the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is this part right here, b squared minus 4ac. So that's what we're going to use to determine what kind of solutions we have. Okay, so we're going to do b squared minus 4ac. So let's just talk about what a, b, and c are. So a equals 6, it's right there. B equals negative 4, and C equals 1, okay? So we're going to do our B squared. So we're going to do negative 4 squared minus 4 times A was 6, and C was 1. So on this problem, we get 16 minus 24. That's going to be a negative number, y'all. That's going to be negative 8. And that means that we have 2 imaginary solutions, right? Because it's negative. So on our next one, again, we're going to subtract 3 from both sides because we got to get everything on the one side of the equal sign. So negative a squared plus 7a plus 3. So again, we need our a equals negative 1, b equals 7, c equals 3. We're doing b squared minus 4ac again. So that's going to be 7 squared minus 4 times a minus 1 times a 3. That's 49. Negative 4 times negative 1 is a positive 4 times 3 is 12. So this can be plus 12. So our answer here is going to be 61, which means it's a positive, but it's irrational because we could take the square root of 61. Y'all got me? We're not going to get a whole number, right? So this is going to be 2 real irrational solutions. Rational means it's basically a whole number, y'all. Okay, could be positive or negative, but it's a whole number. So 23, again, we're going to subtract the 2 from both sides. Negative x squared minus 4x minus 4. A equals negative 1. B equals negative 4. C equals negative 4. Again, we're doing our b squared minus 4ac. So that's going to be negative 4 squared minus 4 times negative 1 times negative 4. So this is 16. If I do the negative 4 times negative 1, that's a positive 4 times a negative 4 is minus 16. So that gives us 0. So when we get 0 here, guys, we're going to have one real rational solution. That's like the ones, guys, where it bumped the graph, or it bumped the x-axis, okay? That's what these are like. All right, 24, again, subtract 2 from both sides here. So when we do that, we get negative 2k squared plus 5k equals 0, right? So a equals negative 2, b equals 5, c, there is no c, y'all, so we're going to say c equals 0. So here we go, b squared minus 4ac, right? So we got 5 squared minus 4 times negative 2 times 0. Well, if I'm timesing everything over there on the right by 0, then I'm going to get 25 here, right? Minus 0. So that's going to be 25. So again, that, if I take square root of 25, I get 5, right? So this is going to be 2 real rational solutions, because I can take the square root of 25 and get a whole number. Okay? All right, so our next one is solving these with the quadratic formula. So here again, we got to move this 10x to the other side. So we're going to do x squared minus 10x minus 11 equals 0. We're going to pull our a, which is 1, our b, which is negative 10, and our c, which is negative 11. We're going to put these in the discriminant first, because that's easier. Okay, so we're going to do negative 10 squared minus 4, that's our a and our c, okay? So that's going to be 100. When I multiply a negative times a negative, I get a positive, right? So that's going to be plus 44. That's going to be 144, y'all. And hopefully all of y'all know that the square root of 144 is plus or minus 12, right? So now we're going to do our negative b, which is going to be minus a minus 10. We got our plus or minus 12, right? All over 2 times a. And a was 1, right? So we're going to simplify this. That's going to be 10 plus or minus 12 over 2, right? So 10 plus 12 over 2 is going to be 22 over 2, which is 11. That's one of our answers. Then we got 10 minus 12 over 2. That's going to be minus 2 over 2, which is equal to minus 1. So those are our two solutions there, 11 and negative 1. Again, we got to put this in standard form first, so we're going to put plus 4x. So we got 10x squared plus 4x minus 1 equals 0. Pulling our a, which is 10, our b, which is 4, and our c, which is negative 1. We're going to do the discriminant first again, so we're going to do b squared minus 4ac. So we're going to do 4 squared minus 4 times a times c. So I get 16. Again, we got a minus times a minus, so that's going to be plus 40, right? Pretty sure that's right. 16 plus 40, that's 56, right, y'all? So this is going to be irrational. I know that for sure, because that's not a perfect square, right, y'all? But let's go ahead and simplify this. So plus or minus, do we have a perfect square that's a factor of 56, y'all? Let's see. What about 4? Square root of 4, yeah, times square root of 14. There we go. So this can be simplified to be plus or minus 2 square root of 14, right? So again, if I simplify this up here, then when I work the rest of my problem, I'm just having to plug that in, what was underneath that radical, y'all. So at this point, I'm going to go ahead and do minus b, which is minus 4, plus or minus my 2 square root of 14 over 2 times a, which is 10. So this is going to be minus 4 plus or minus 2 square root of 14 over 20, right? So now we're looking for a GCF, okay? Our GCF is going to be 2, right? No, wait. Yeah, 2 because of the 2 on top up here up in front of the square root of 4. So this is going to be negative 2 plus or minus square root of 14 over 10. That's as simple as it gets. All right. So number 27, again, I'm going to move everything over here. So I'm going to do plus 4 minus 5x. So I'm going to do 4x squared minus 5x plus 4 equals 0. A equals 4, B equals negative 5, C equals 4. Going to do the discriminant again, so I'm going to do negative 5 squared minus 4 times A times C. So this is going to be 25 minus 64. So that's a minus 39. And again, if we take this, the square root of this, plus or minus, right? So this is going to end up being plus or minus the square root of negative 1 times the square root of 39. I can't simplify the 39. There's no perfect square that's a factor of it. But this is going to be plus or minus I square root of 39. So this is going to be irrational, y'all. Actually, take that back. This is going to be imaginary. So here we go again. So we're going to do our minus a minus 5 plus or minus the I square root of 39 over 2 times 4, because that was our A. So this is going to actually be positive 5, right, y'all? Because minus a minus is positive, plus or minus I square root of 39 over 8. And that one cannot be simplified anymore. All right, again, going to move the stuff on the right to the left. So that's going to be plus 10 plus 11n. So that's 3n squared plus 11n plus 10 equals 0. A equals 3, B equals 11, C equals 10. So we're going to do 11 squared minus 4 times A times C. So that's going to be 121. 4 times 3 is 12, times 10 is 120. So that's going to be 121 minus 120, which is 1, y'all. And the square root of 1 is plus or minus 1, right, y'all? So here we go. Negative 11 plus or minus 1 over 2 times 3. So that's going to be negative 11 plus 1 over 6. That's going to be what? Negative 10 over 6, which is going to be negative 5 over 3. And then negative 11 minus 1 over 6. That's going to be negative 12 over 6, which is going to be negative 2. So those are our two solutions here, guys. So our last set of questions here ask us what type of zeros are represented in the graph, and if they are real, what are they? So first of all, the first one, 29, does not cross the x-axis, so this has two imaginary solutions, right? What about the next one? The next one looks to me like x equals negative 3 and x equals negative 1. So it's got two real rational solutions, right? Then number 31 looks like x equals 2 and x equals 6. Again, we have two real rational solutions. And then the last one looks like x equals 0 and x equals 2. So here again we have two real rational solutions. Okay?